The second unit of optical communication deals with channel impairments. So under channel impairments, we are going to study fiber loss. It's mainly due to attenuation. Under attenuation, we are going to study about absorption, scattering and bending. Along with that, we have core and cladding losses. And coming to dispersion, we have two types of dispersion, intramodal and intermodal. Under intramodal, we have to study material dispersion and waveguide dispersion, followed by intermodal dispersion. And we have one important dispersion called as polarization mode dispersion, followed by characteristics of single mode fibers and optimization of refractive index profiles, and then how to calculate the dispersion. Coming to the first topic, fiber loss under unit 2. So we are transmitting a signal through the fiber. The electrical signal is converted to optical signal by using the lasers, by using the light sources such as LED and laser, and the optical signal is transmitted through the fiber. It may be degraded by two important factors. One is attenuation and second one is dispersion. The power loss, whatever happens, is called as broadly classified as attenuation. Attenuation in optical fiber mainly caused by three factors. What are they? First one, it is absorption. Second one is scattering, and third one is radiative losses or bending losses. We'll see one by one. Attenuation. What is attenuation? Attenuation is a measure of signal strength or loss of optical power when the signal travels through the length of the fiber. If the length is more, attenuation is also more. Both are directly proportional. We can define the signal attenuation as the ratio of optical power input, that is PI, to the optical power output Pout. So what is PI and what is Pout? PI is the power which is injected into the fiber from an optical source. What is Pout? Pout is the optical output power that is received or taken at the end of the detector. So main causes of attenuation are, it will reduce the system bandwidth and it will decrease the efficiency, and finally it brought down the overall system capacity and information transmission rate. So this diagram shows wavelength versus attenuation. So optical communication mainly operating in three important windows. First window, second window and third window. First window is centered around 850 nanometer and second window is operating around 1310 nanometer, and the third window working on 1550 nanometer. So in the 1300 window where dispersion is very less, whereas in the third window the attenuation is very less. That's all we can infer from the diagram. So signal attenuation, it determines the maximum unamplified or repeaterless distance between the transmitter and receiver. So we have to find the distance between transmitter and receiver without the help of repeaters. Okay. So what will happen if the signal distortion happens? It causes optical pulses to broaden, and it will overlap with the neighboring pulses and produces error at the output. So we can't distinguish the pulses whether one has been transmitted or zero has been transmitted. Due to the pulse broadening, we can't determine what is the pulse we have transmitted at the source end. Hence, it limits the information carrying capacity of the fiber. Broadly, signal loss is called as fiber loss. Attenuation is directly proportional to the length of the cable. Attenuation is defined as the ratio of optical output power to the input power in the fiber of length L. Normally, attenuation is referred as alpha equal to 10 log 10 Pi by Pout. Normally, it is represented in dB per kilometer, where Pi is the input power and Pout is the output power. whereas alpha is the attenuation constant. So we have three types of attenuation, namely first one absorption loss, second one scattering loss, and third one is bending loss. Absorption loss mainly it is caused by the impurities present in the fiber such as water and metals. Under absorption we have intrinsic absorption and extrinsic absorption. Second type, scattering. Scattering loss, it is mainly caused by interaction of photons with the glass. Here we have two types, linear scattering and non-linear scattering. And in bending loss, third category is bending loss or radiative losses, in which the loss is mainly caused by the physical stress on the fiber. So here we have two types, namely microscopic bending and macroscopic bending.